Hello everyone, welcome back to my channel. As we all know, 10th ICSE exams are going on. I hope all students are doing well. Today in this video, we will discuss about important problems from one of the important chapter, current electricity. Let's get started. Before solving problems, let's quickly recall some important formulas used in this session. Term voltage is represented by symbol V and formula is V equals I into R. This is also known as Ohm's law. And it is measured in terms of volts. Voltage source can generally be a battery. Battery is generally represented with positive and negative terminals. But general representation of an voltage source is like this. Now next, current. It is represented by symbol I. I equals V by R. It is measured in terms of amperes. Ammeter is a device used to measure current. It is represented as A. To measure current. Next, resistance is connected in series. It is represented by R and R equivalent is R1 plus R2. That is sum of the resistances. And we know that unit used to measure resistance is ohms. It is represented by resistance symbol. For series connection, simple representation can be done like this, R1 and R2. Now next, resistance is connected in parallel. It is also given by R. R equivalent is 1 by R1 plus 1 by R2. Unit ohms. It is generally represented like this. R1 and R2 resistances are connected in this form. Now moving on to problems. This type of question is most expected question from exam point of view, where we need to find equivalent resistance of a given network. Here we need to find equivalent resistance between point A and Y in this network. To find equivalent resistance, first we need to know what is series and parallel connection. To know about series connection, let us consider two resistors as R1 and R2. Then let us consider current I flows through this network. Now we can see that for current I to flow there is only one path. First, current I will flow through resistor R1, then same current I will flow through resistor R2. As same currents flows through both the resistors, it is known as series connection. Equivalent resistance will be R1 plus R2. Now, we will discuss about parallel connection. For parallel connection, to understand or identify the resistors are connected parallelly, let us consider a network with resistors as R1 and R2. R1 and R2 as shown, where current I flows in this network. When current I reaches the point here, it will have two paths as shown. So it will get split. It will split into two paths. Let us consider that current I is divided into two parts like I1 and I2. Then the part of the current I1 will flow in the direction of R1 and in I2 will flow in direction of R2 resistors. This type of connection where current will get split is known as parallel connection. And again after that point it will get combined where total current now will be I1 plus I2, that is I. For this type of connection, resistance is given by 1 by R1 plus 1 by R2, which is equivalent to R1 into R2 by R1 plus R2. Now, to find equivalent resistance of the network between points A and Y, let us consider current I at point A will split into three paths because it has three different paths. In part of 5 ohm resistor, consider part of current I1 will flow. Same current will flow in 3 ohm resistor because there is only one path. When same current is flowing into both the resistor, it is known as series connection. So 5 ohm and 3 ohm are connected in series. Now similarly here also take part of current I2 is flowing in 1 ohm, same will flow in 3 ohm also. So it is known as series connected. For series connection, we know that formula for equivalent resistance is R1 plus R2. So find that equivalent resistance 5 plus 3 ohm will be 8 ohm. Similarly, for this path 1 plus 3 ohm will be 4 ohm. Now we will draw an equivalent circuit. For equivalent circuit, we know that both 5 ohm and 3 ohm resistors now are combinedly can be written as 8 ohm resistor. Similarly, 1 ohm and 3 ohm resistor combinedly can be written as 4 ohm resistor. We'll retain the 8 ohm in middle as it is and we'll replace 1 ohm and 3 ohm with 4 ohm resistor. And this is point A and this is point Y. Now you see at point A again current has three different paths. It will get divided. When current is getting split, it is known as parallel connection. For parallel connection, we know the formula R1 into R2 by R1 plus R2. We'll use this formula for the first two resistors, that is 8 ohm and 8 ohm. 8 into 8 by 8 plus 8 will be 64 by 16. This is equal to 4 ohm. Again we'll draw equivalent circuit. In equivalent circuit, now we'll replace both 8 ohm by 4 ohm and we'll retain 4 ohm resistor. This is point A, this is point Y. Now again current has two different paths. This one path, this one path. So it is again known as parallel connection. For parallel connection, we again use this formula. We'll use 4 into 4 by 4 plus 4. That is 16 by 8. Now it is 2 ohm. So equivalent resistance is equal to 2 ohm. So it is so simple. Now let's solve another type of question which is also very important from exam point of view. In this question we need to find potential difference and current across a resistor in a circuit. To solve this type of questions, let's understand what this table mean. It is very important. In series, current will be same, voltage will be different. In parallel, current will be different, voltage will be same. That is, for example, consider these two resistors which is connected parallelly. As we know that current I has two paths, it will split into I1 and I2. Current is different across the resistors connected in parallel. So, it means current is different. But voltage will be same across these two resistors. That is V1 and here also it will be V1 or VV. This is the actual meaning of this table. Now let's solve the question. For question A, what is the current through 8 ohm resistance? To find current through 8 ohm resistor, let us consider current I, that is total current I will be flowing in the circuit. At this point it will get split into I1 and I2 and this point it will combine. That is the current I1 plus I2 will be flowing in 8 ohm resistor. That is nothing but the total current I. If current flows in this direction. Now let us consider if current flows in this direction. Then the total current I will directly flow in 8 ohm resistor. At this point it will split, again it will combine here. Similarly, entire current will flow in all complete circuit. So in both the directions, entire current I will flow in 8 ohm resistor. So we should find the entire current. First, we need to find R equivalent because we know that I equals V by R equivalent. So we see these two resistors are connected parallelly because current is splitting. For parallel connection, we know the formula R1 into R2 by R1 plus R2. So here R1 is 12, R2 is 6. So 12 into 6 by 12 plus 6, which upon solving, which will be 12 into 6 by 12 plus 6 will be 18. So 6 ones are, 6 threes are, 3 ones are, 3 fours are, which will be 4 ohm. Now we can draw equivalent circuit as shown. We have a voltage source of 12 watt. Now we have an ammeter connected. A means ammeter. It is a device used to measure the current. Now 8 ohm resistor, both 12 ohm and 6 ohm can be replaced by 4 ohm resistor. 4 ohm resistor is connected as shown. Then we have a simple switch as shown in circuit. Now we know that same current will flow in resistor 8 ohm and 4 ohm because there is only one path. So it is connected in series. For series connection, we know the formula R1 plus R2. So 8 plus 4 equal to 12 ohm. So R equivalent is 12 ohm. Now we know V equals I into R. From this, I equals V by R. V is 12 watt, 12 volt divided by R is 12 ohm. And we can derive an equivalent circuit as we have a same voltage source, then an ammeter, then both 8 ohm and 4 ohm can be replaced by single resistor 12 ohm and complete closed circuit. 12 volt. Now 12 volt and 12 ohm will get cancelled and we have 1 ampere as current. As we know, total current I is flowing in 8 ohm resistor. It is 1 ampere current is flowing in 8 ohm resistor. Now for question B, what is the potential difference across parallel combination of 6 ohm and 12 ohm resistor? To find this, we have voltage source of 12 volt. That is, total voltage will be 12 volt or potential difference. It will be 12 volt. We know that potential difference across 8 ohm resistor will be I into R. That is, I in 8 ohm resistor is 1 ampere. We are found in question A. And R is 8. So it is 8 volt. Now we know total is 12 volt and 8 volt is across 8 ohm. So remaining will be 12 minus 8. That is 4 volt. So remaining 4 volt will be seen across this parallel connection 12 ohm and 6 ohm. This is the answer for B question. So see, what is the current through 6 ohm resistor? We know that potential difference across this parallel connection is same. That is VV. We have found it as potential difference across this parallel connection is 4 volt in question B. So as it is same, 4 volt will be across 12 ohm and also it will be across 6 ohm. It will be same. So we know voltage and resistance. So I will be V by R. Voltage is 4 volt and resistance will be 6 ohm. 4 by 6. It is 6 ohm. In question they asked across 6 ohm resistor. So it is 2 by 3 ampere current. We have solved all 3 questions. Now next question where we need to find equivalent resistance between point A and point B. For this, let us consider a current I as I have explained in previous questions. When it reaches this point, current I has again 3 paths. First path in 4 ohm, again in this 4 ohm resistor path, again in this 2 ohm resistor path. Now let us consider current I1 is flowing in this 4 ohm resistor and current I2 in this 2 ohm resistor. Now I3 in this middle 4 ohm resistor. Now this I1 after flowing in 4 ohm, again same current will flow in this 4 ohm and again in this 4 ohm. Because there is only one path. When same current flows through the resistors, it is known as series connection. All these resistors are connected in series. Now similarly, same current I2 will flow in all 3 2 ohm. 2 ohm resistors. So we can say even all these 3 2 ohm resistors are connected in series. Now for series connection, we know the formula that R equivalent is the sum of the resistance, that is 4 plus 4 plus 4 ohm. So when we add up all this, we will get it as 12 ohm. Similarly, we can find for bottom path also, that is 2 plus 2 plus 2 ohm. That is nothing but 6 ohm. Now we will draw equivalent circuit. Now we will retain 5 ohm resistor as it is, and point A, we know that all 3 4 ohm resistors are replaced by 12 ohm. After that, in the middle 4 ohm resistor is retained as it is. Again we know that entire 2 ohm 3 resistors are replaced by 6 ohm resistor. Then we have one resistor 8 ohm and point B. This is the equivalent circuit. Again consider current I. At this point it will split into 3 parts because there are 3 parts, I1, I2, I3. When current is splitting, it is parallel connection. Let us apply parallel connection formula. Let us apply it for first two resistors 12 ohm and 4 ohm. That is 12 into 4 divided by 12 plus 4, which is equivalent to 12 into 4 by 16. That is 4 ones are 4s are 4 ones are 3s are, which is equivalent to 3 ohm. Now again we can draw the equivalent circuit as retaining 5 ohm as it is, point A. Now both 12 ohm and 4 ohm are replaced by 3 ohm. Now again retain 6 ohm as it is and 8 ohm as it is, and we will put point B here. Now again current is splitting into 2 parts. So again it is a parallel connection. 3 ohm and 6 ohm are parallelly connected. Again apply formula as 3 into 6 by, that is R1 into R2 by R1 plus R2. 3 into 6 divided by 9, that is 3 ones are 3s are 3s are 2s are, it is 2 ohm. Now again we will draw an equivalent circuit. By this it is very easy to solve by drawing equivalent circuits. Again 5 ohm as it is retained, and both 3 ohm and 6 ohm are replaced by 2 ohm resistor, and again 8 ohm is retained as it is, and point B. Now we can see that same current I will flow in all 3 resistors 5 ohm, 2 ohm and 8 ohm. So it is series connection. For series connection we know equivalent resistor is sum of resistances, that is 5 plus 2 plus 8 15 ohm. So equivalent resistance is 15 ohm. Drawing equivalent network diagram at every step makes the problem simple. Let us discuss another question. In this question, we need to find V1, V2, V3 voltages and current through the ammeter A. First question, reading of ammeter means we should find current through the circuit I. To find the current, we need to find R equivalent of the circuit. Let's find R equivalent first. We know that this both 6 ohm and 3 ohm resistors are connected in parallel because current will get split. So we will find the R equivalent of 6 ohm and 3 ohm. To find R equivalent of 6 ohm and 3 ohm, we know the formula R1 into R2 by R1 plus R2. So your R1 is 6 ohm, R2 is 3 ohm. Let's substitute the values in this formula. 6 into 3 divided by 6 plus 3, that is equivalent to 18 divided by 9, which is nothing but 2 ohm. Now before moving into next step, it will be easier if we draw equivalent circuit. We will draw equivalent circuit. In equivalent circuit, all the elements will be same except 6 ohm and 3 ohm resistors. As 6 ohm and 3 ohm resistors, equivalent resistance we have found out to be 2 ohm. So that will be only replaced by 2 ohm resistors as shown. After drawing equivalent circuit, we will attach the voltage sources V1, V2 and V3 across the respective registers which was given in the question. Now we know that same current I will flow through all the resistors. So it is connected in series. For series connection, we know that equivalent resistance will be sum of the resistances. That is 1.5 ohm plus 2 ohm plus 8.5 ohm. That will be equal to 12 ohm. So equivalent resistance is 12 ohm. For first question, to find the reading of the ammeter, that is current through the network, we know that I equals V by R. V is 24 volt and R is 12 ohms. We have found out. So simplifying this equation, we'll get 2 amps as a current. Now moving on to second question, that is B. We should find V1, V2, V3. V1 is I1 into R1. I1 is current through 1.5 ohm resistor, that is nothing but I. I we have found out to be 2 amps into R1 is 1.5 which is equal to 3 volt. Now for V2 similarly I2 into R2. Here even I2 is 2 amps because I2 is equal to I only. Then R2 is 2. So 2 into 2 will be 4 volts. For V3 we should find similarly I3 into R3. I3 is nothing but I, that is 2. 2 into R3 is 8.5 which will be equal to 9, no sorry 2 into 8.5 is 17 watt. Now we know that total voltage given is 24 volt. So we can cross verify that all the voltages we have calculated is proper by adding them. 3 plus 4 plus 17 should be equal to 24 volts. So answer is correct. Now we can find V through by other method. We know that voltage across 1.5 ohm and 8.5 ohm resistors. Now to find the voltage across 6 ohm and 3 ohm resistor, we know total voltage is 24 volt. So by subtracting V1 and V3 by total voltage, we will get V2. That is voltage across 6 ohm and 3 ohm resistor. 24 minus 7 will be V2. That is 17. So we are obtaining same answer as we obtained in previous method. That is 17 volt. I hope you have understood how we solve this question. Now let's move on to another one last question for this session. For this question, we need to find the total resistance and total current flowing in the circuit. For first question, to find the total resistance of the circuit, we know that current is flowing in this direction as given in the network. Now at this point, current will split. Once the current will split, we know that resistors are connected in parallel. Then again at this point current will combine and again at this point it will split. So again these two resistors R1 and R2 are connected in parallel. Now we will find the equivalent resistors for both the loops. For this loop it is R1 into R2 by R1 plus R2. So 10 into 40 by 10 plus 40. That is nothing but 400 divided by 50. After simplifying this, we will get it as 8 ohm. For second loop, we can use as 1 by R1, that is R3 plus 1 by R4 plus 1 by R5 formula because we have 3 resistors. 1 by 30 plus 1 by 20 plus 1 by 60. By taking LCM as 60, we can simplify the equation as 30 into 60 will be 2. 2 plus 20 into 60 will be 3. 3 plus 60 into 60 will be 1. So 6 by 60. So this is This is 1 by 10. This is 10 ohms. Now we will draw equivalent circuit. In equivalent circuit, we can replace the first loop, that is 10 ohm and 40 ohm resistors, by the equivalent resistor which we have got 8 ohm resistor. Then similarly we can replace the 30, 20 and 60 ohm resistor by 10 ohm resistor. We'll keep voltage source and switch as it is, that is switch K, 12 volt voltage source, 8 ohm and 10 ohm. This is the circuit we have obtained. Now we can see that current through 10 ohm and 8 ohm will be same. That if current I flows in 8 ohm resistor, then same current I will flow in 10 ohm resistor. Therefore both are connected in series. For series connection we should add up the resistances. R equivalent will be 8 plus 10, that is 18 ohm. Now for part B, to find total current flowing in the circuit, by Ohm's law we know that V equals I into R. So I equals V by R. We know that V is 12 volt. 12 volt divided by R is 18 ohm. We will get as 6 by 9, that is 3 by 2. 2 by 3. So I is 2 by 3 amperes. That's it for this session. In next video, we will discuss about remaining important problems from the same chapter. So stay tuned for the part 2 of this video. If you like this video and you felt if this video was useful to you, please do like, share and subscribe to my channel Simple Learning, and press bell icon to get notified regarding all the further upcoming videos on my channel Simple Learning. Thank you.